For the most part, graphs and statistics are created to support a business or a company's motive or maybe somebody's point of view. So when they're creating these graphs, they want to make them look good or maybe even make the other companies or the other point of views look bad. Now this isn't always true, but it happens. And you as the reader in this world that you live in, really need to be a skeptic and always analyze what you're seeing and what you're hearing. Is this true? Is this the whole story? And really study up and learn more whenever you run into something that you're not sure if this is the whole story. Here's an example of how a graph or statistic could be misleading, and this actually was on TV within the past couple of years. Verizon had a commercial and they showed this map right here, and they said that Verizon had 5 times the more 3G coverage as AT&T. And like I said, when a graph or statistic is misleading, it doesn't mean they're lying, but it's presenting the data in a certain way. Now, when I saw that commercial, I was like, wow, Verizon's definitely a better company. They offer more coverage. Look at all the places. All the white is probably where AT&T doesn't have coverage. That's crazy, So I'm thinking, well, I would go with Verizon for my cell phone because if I'm traveling and moving around, I want to make sure that it works. However, this is kind of misleading. And there's an article about this. Like I said, AT&T took Verizon to court over this. And here's a little explanation of it. So really, the map attributed to AT&T shows large patches of white, right? And so we think that as if these are areas that AT&T has no coverage whatsoever. By depicting AT&T's non-3G coverage as white, the consumer might be misled to believing that AT&T's customers had no coverage whatsoever in those areas. And that's exactly what I thought, when really they have coverage in those areas. It just might be 2.5G or something less than that. AT&T, when they created their own map, this is what it was. Well, that looks pretty comparable to Verizon. It doesn't look very different. And so seeing this next to the red maybe would have been more fair, because I assumed that the white meant that AT&T had no coverage. Now the graph is not lying. Look, it says it has 5 times more 3G coverage, okay? But they may have coverage of another type, maybe 2.5G in that area, and so it may not be as big of a difference. As we read on this article, and this is found on Apple Insider, it's pretty cool, but as I read on in this article, in all the advertisements described above, AT&T's statement says Verizon makes the misleading statement that it has 5 times more 3G coverage than AT&T. While this statement is literally true based on square miles, so when you look at the square mileage of Verizon's 3G coverage, it is 5 times the square mileage as AT&T's coverage. But listen to this part. It is misleading because the overwhelming majority of the U.S. population lives and works where both Verizon and AT&T have 3G coverage. So I think what they're saying here is, maybe a lot of these spots, there isn't a heavy population where they don't have 3G coverage. It's not affecting as many people as it looks like. And also, this is pretty important. So indeed, from a population standpoint, if you focus on the number of people, Verizon only has 1.24 times more 3G coverage than AT&T. 285 million versus 230 million. So that is a much closer difference. Verizon still does have more, but it's not as extreme as this picture here. So be a skeptic, read, really analyze what you see. These advertisements are all over the world, and you are going to be the one having to interpret them. So that's what we want to practice today. Copy down your target. I want to work with you to recognize misleading graphs and statistics, show you a couple ways that this could happen, and so that way you'll know some ideas of what to look for. At the end of the day, though, I really think you just have to know as much information as possible. If you're not sure if something is misleading, you need to do the research, and you need to check out what companies are creating these charts, and if the other company has their own chart, and really compare where the data came from. So make sure you have your target written. Let's take a look at a couple graphs here. Example 1, I'm going to show you 4 different graphs. We're going to do a line graph, 2 bar graphs, and a picture graph, and a couple different ways that they can be misleading. So please write these down. You will have more writing today. You may need to pause the video if I'm writing too quickly. So let's look at this first graph, explain why the graph is misleading. Now again, there doesn't necessarily have to be something wrong, but maybe the advertiser is accidentally or intentionally presenting the information in a misleading way. So when you look at the graph, when you're trying to decide what's misleading, try to find something that it leads you to believe or that may be incorrect. When I look at this graph, what do you think about the stock value happening over time? Sure looks like it's increasing, and that is true. But what does it lead you to believe? For me, I think when I look at this, I'm going to believe that it's going to be continuing to increase. And 2020, that hasn't happened yet. So can we predict that the stock value is going to be at 30 in 2020? We can't really say that. The future's not set. So for this first graph, I would say this graph, it suggests or leads me to believe that the stock value will continue to increase. At least up to 2020, because that's what they're showing. But there is no way to foresee the future. We could show the graph up to this current year, but you really can't show it for future years because we don't know that that's really going to happen. That is a misleading graph for sure. All right, if you need to pause, copy that down, then we'll go on to the next one. Let's look at this second one with the shoe sales. Now again, you're looking for something that maybe something specific that causes you to misinterpret this graph. Let's look at these. So we got 3 brands. The bars are really close together. They're all right around here. So let's see what they're all between. They're all really between 60 and 40,000. When I look at this graph, I think, well, why all this space up here? Do I really need my scale to go to 100,000 if all my bars are less than 60,000? And that is actually a way that you can mislead somebody. Why? What does that cause you to interpret? And how would this graph look different if you still scaled up to 60,000 but it was all the way up here? So maybe if it was 10, 20, 30, 40, 50, 60,000. The scale on the y-axis it really goes beyond what it needs to. So say something about the graph that is causing the misinterpretation, and then put a comma, and let's say what that causes us to believe. So because of the scale going way beyond what it needs to, let's think about this. If we push 60,000 all the way up to here, what would happen to the differences between the bars? Right now they look really close, but you could even redraw this. The bars would probably look more different, and the brands would not all appear to be almost the same. So the scale on the y-axis goes beyond what it needs to, which makes the brands appear to all be almost the same. Whereas if I stretch that back out, it would appear the bars would have bigger differences and they wouldn't look so close together. So when you look for something that's misinterpreting, say what is causing the misinterpretation, and then say what this makes you believe. Try to be as specific as possible. Let's look at another bar graph. School play ticket sales. When I look at these, let's take a look at this graph. So wow, 6th grade right away. I'm thinking 6th grade. I mean, it's like 2-3 times the amount of 7th grade, maybe 8th grade even. Definitely looks at least double the sales of 8th grade. But 6th grade sold 120, 8th grade sold 100, 6th grade isn't actually double of 8th grade. So what caused me to misinterpret that? This break in the graph right here. You probably already caught it. If you did, that's awesome. Yeah, the break in the graph, and I might even say the break on the y-axis. So that's what causes me to misinterpret. And then tell me specifically how you misinterpreted this. So the break on the y-axis, it really exaggerates the bars differences, but then I'm going to even go a little bit farther. It appears, you can't say that it appears that 6th grade sold more than 8th grade, because that actually is true. You want to say something that's not true. So I'm going to say it appears that the 6th grade had double the ticket sales as 8th grade. And that is something that is not true. I'm only interpreting it that way because the break in the graph causes those differences between the bars to be exaggerated. Perfect. Last graph here. Okay, let's look at this one. Again, it's kind of like a bar graph, but it's pictures, and we have trash cans per household, and we have the years. And so we can see that it's 1960, 1980, 2000, and you know the it looks like the area of the trash can. I mean, it looks like the trash cans per household really increased over time. Okay, and I'm not saying that that's not true, but what causes a misinterpretation? Again, when you create a picture, if you have a circle or a shape and you enlarge the area, that makes a big difference. Again, look at this. This is about between maybe like 75. This is about 150, but I would say I could put maybe 4 of these in to make that one big trash can. So that's a problem. The area of the trash cans distorts the comparison. And then try to tell me how. When I look at this, okay, so I would say the 2000 trash level is actually double the 1960 trash level, but it appears to be 3 to 4 times the 1960 level. So I always try to say something that I believe is true from looking at this, but it's not actually true. Perfect, guys. The next part of this is going to explain how statistics can be misleading, and that's going to be shorter, so one more video to go.